Hi, welcome to the demo session on VLSI by Expert HDL and Chip Design, a professional VLSI training institute. Caution statement. This video presentation contains confidential information and information that is legally privileged to Expert HDL and Chip Design. This video presentation is only to be used by the intended recipient. Unauthorized use of this video presentation, downloading, or sharing this video presentation without the consent of Expert HDL and Chip Design is subject to legal action. No photography or no downloading.
You can view our free demo lectures on these topics: Semiconductor Overview, which covers the fundamentals of semiconductor, some history about electronic semiconductor industry, overview of semiconductor industry in India, and opportunities in semiconductor industry in India. Integrated Circuit Design Process. What is VLSI in VLSI Overview? Verilog HDL Overview. Introduction to Verification Flow and various verification methodologies in Verification Overview. System Verilog and Universal Verification Methodology Overview. Overview about Expert HDL and Chip Design, VLSI Training Institute. Please note these are demo lectures and will cover some partial portions of the topics from our full courses. The information will be partial. To learn the course in detail and full, please sign up for our full course online or in classroom today. Before we learn about VLSI and opportunities in VLSI domain, let us try to understand the issue we are trying to address over here. Most electronics engineers after graduation either go for higher studies or take up a job, but most of them either end up working in an IT or software domain or become an MBA graduate and work in a finance or marketing domain. Why not explore the domain of core electronics in integrated circuit design and verification?
We at Expert HDL provide you with a launchpad to launch a career in the electronics industry.
In this demo module, we will learn about Verilog hardware description language and share some basic concepts in Verilog HDL. To learn Verilog HDL for design and verification in detail, please take our online certification course in Verilog HDL today.
Verilog is a widely used hardware description language for design and verification of integrated circuits in semiconductor industry. In this tutorial, you will learn Verilog hardware description language and its coding constructs for integrated circuit design and verification. Let us now shift gear and learn a little bit more about HDL and different design techniques in today's world. In earlier technology nodes, electronic circuits were directly designed in layouts because of low count of transistors. As complexity increased, designs were realized in form of logic and connected using EDA tools to generate the layouts. But to design complex integrated circuits like microprocessors which have millions of transistors, it is very difficult to design layouts or logic design directly. It will take years to complete and will not be efficient. Also, it is not practical to run extensive simulations on complex transistor level designs to check for functionality. This is why hardware description language comes into the picture. Because of hardware description language, or HDL as we reference it, it is possible to design complex circuits quickly. So what is really this HDL process? Well, HDL translates features of hardware device into a program which is checked for correctness through simulations. Then, using synthesis, this HDL can be translated to a gate level design and finally to an electronic circuit using place and route tools. Synthesis decreases design time by eliminating the need to define every gate. In addition, synthesis tool can apply automation, such as machine encoding styles or automatic I/O insertions during optimization, resulting in greater efficiency. With HDL, it is easy to verify the design's functionality and early in the flow by simulating the HDL description. Testing the designs at register transfer level or gate level before the design is implemented enables to make changes early in the design process and reduce the cost of development. It also enables to reuse same design blocks with different architectures in future. In digital design circuits, register transfer level is a design level abstraction which models a digital circuits in terms of flow of digital signals or data between the hardware registers, the logical operations performed on those signals, and mostly used for synchronous systems. When designing digital integrated circuits with a hardware description language like Verilog, System Verilog, or VHDL, the designs are usually engineered at register transfer level, then translated to a transistor level or logic families or logic or gate level. From this level, lower level representations and ultimately actual wiring can be derived. In HDL, the designer declares the registers, which roughly correspond to the variables in computer programming languages, and describes the combination logic by using constructs that are familiar from the programming languages such as if then, else if, and arithmetic operators. The term RTL refers to the fact that it focuses on describing the flow of signal between the registers. For example, to design an adder to add two inputs and store the sum value in a register to be used for the next operation, an RTL can be described in HDL like Verilog. Declare variables for the inputs B and C and an output A. At every positive edge of the clock, new values of B and C will be captured, added, and stored in the variable A, which is nothing but a simple register or a flip-flop. The output of that register can be connected to the next stage in the logic flow. This will be the actual hardware realization of this Verilog code, where B and C go through an adder and the output of the adder is eventually stored in a register controlled by clock. Current industry standard for design is Verilog hardware description language for small ASICs and for system Verilog for complex SoCs like processor. System Verilog incorporates all the good features of Verilog for design plus enables complex verification of the integrated circuits. The primary difference between VHDL and Verilog is VHDL is harder to learn, Verilog is easier to learn and more like C. Let us look at some of the history of Verilog. In 1984-85, Philip Morby at Gateway Design Automation invented Verilog. In 1989, Cadence Design Automation acquired Gateway and its hardware description language. In 1990-91, Cadence put Verilog HDL into open source domain for public to use for free. In 1994-95, Verilog became an IEEE standard, IEEE 1995. In 2001, revised editions of Verilog were released as IEEE 1364-2001 edition, and in 2005, with enhanced features and some modifications based on user feedback, an IEEE standard 1364-2005 was released, which is the current Verilog edition being used. Also in 2005, System Verilog, a superset of Verilog, was released with enhanced object-oriented programming capabilities. Verilog is maintained by Accelera, a non-profit organization. So what is this Verilog HDL2? Verilog is a widely used hardware description language in industry for design and verification of integrated circuits. Verilog HDL allows a hardware designer to describe designs at higher level of abstraction such as architectural level or behavioral level, as well as lower levels of abstraction, that is gate and switch level. It can be used for behavioral and structural design realizations. Main advantage of Verilog is that it can be used for both design and test bench together. System Verilog is a superset of Verilog 2005. It is object-oriented, which enables a lot of automation, especially in verification environment. The features of System Verilog can be divided into two distinct roles. System Verilog for RTL design is an extension of Verilog 2005. All the features of that language are available in System Verilog. System Verilog for verification uses extensive object-oriented programming techniques and is more closely related to Java than Verilog.
Keywords are reserved identifiers which are used to define language constructs. For example, always keyword used for always procedural block, module and end module keywords used for definition and beginning and ending of a design, and so on. Listed here are all the keywords.
Comments can be added to Verilog code for reference. It is always a good practice to add descriptive comments in the code. This enables different users to understand and interpret the code easily. Also, comments should be added for each important section with either just before the section or on the same line. Single line comments must begin with two forward slash and should complete on the same line. It is not required to start a comment from the start of the line. This is usually used for adding short comments or descriptions about the identifiers. Multiple line comments must begin with a forward slash and an asterisk mark and end with an asterisk and a forward slash on any other line. Between these comments can be added on multiple lines, good for long description section comments. Nesting of comments within a comment is not allowed. Size-based constants are represented by width, arithmetic base of the number, and the value. Width in the number of bits followed by grave accent mark or tick mark followed by the base number radix. Example B for binary, hex for hexadecimal, O for octal, D for decimal, followed by a number in that base number system. For example, binary number with 3 bits can be represented as 3 tick B101. A hexadecimal number with 4 numbers as 16 or 16 because hexadecimal number translates to 4 binary bits. 16 tick H for hexadecimal followed by a number between 0 to F in hexadecimal format. A decimal number can be represented by number of bits in binary, so a 4-bit decimal number translating to 32-bit decimal, 32 tick D for decimal followed by the number in decimal format. If the number of bits are skipped, it is assumed to be based on the length of the number that is defined. For binary, hexadecimal, and all other formats except for decimal, it is mandatory to specify the radix. If there is no radix defined, it is assumed to be a decimal format. Let us look at different data types in Verilog. Different data types in Verilog are nets and registers, which are categorized for structural data types, integer, real, time, and event are behavioral data types. The two main data types are nets and registers. Nets are used to represent connections between two primitives, just like wires in electronic circuits. They do not hold any value and always need a driver for a valid value. Nets cannot be initialized since it will not hold a value. If a net is not driven, it will assume high impedance or Z state. If a net is driven with multiple drivers with different values, for example, two drivers driving a net 0 and 1, net will assume unknown state or X state. Different types of nets are wire. This is the most basic type of net, most widely used to connect different primitives. Wired AND, WAND WAND. It is combination of an AND gate and a wired output. It can have multiple drivers and the wired output is AND result of all the drivers. Wired OR, WOR. It is a combination of an OR gate and a wired output. It can have multiple drivers and the wired output is OR result of all the drivers. Try, same as wire, but will be 3-stated in a hardware. Registers. The next most important data type is registers. Registers represent data storage. It resembles like a memory element in a computer. It stores value assigned until it is assigned by a new value in an initial or an always block. Registers are of only one type and defined as reg in Verilog, unlike nets. Registers are used to model, latch, flip-flops, and other memory elements in the design in Verilog. For example, A and C are declared as type reg. A is assigned a value 1. Until next event where A is assigned a value 0 comes, it holds the value 1. Hence, when C is assigned a value A, C assumes value 1. C assumes value 0 explicitly until then C holds the value 1. A register may be assigned value within a procedural statement, a user-defined sequential primitive, a task, or a function. A register object may never be assigned value by a primitive gate output or a continuous assignment.
With the knowledge of basic operators and code constructs of Verilog, let us now look at how a Verilog code is constructed. The most basic building block of Verilog code is module. Module is like outer frame or top level boundary of any design. It encapsulates the whole design and provides interface IOs to connect to that design. Similar to a circuit which will have a specific functionality inbuilt but have a boundary and IOs to which the other systems interact with. Inputs are given to these modules, certain functionality is executed, and outputs are driven by these modules. Modules which comprise of interface and design behavior is used in Verilog and allow us to build a hierarchical design from top down. We define one or more base modules which is instantiated one or more times in a higher submodule. These submodules are then instantiated as long as intended until a top level module. This hierarchical approach gives us flexibility to reuse the design and not requiring to code the design again and again. A simplest example of this approach is a full adder design. User defines one module with half adder functionality. Two of these half adder modules are instantiated in one top level full adder module. This saves the user to code the half adder code twice in a top level flat module. Now that we have looked at various Verilog code constructs, let us look at resets in Verilog. Resets in any digital design circuits are very important, similar to clocks. So why are really resets required? The purpose of a reset is to force the circuit into a predetermined or a default value or a known state either on power up or during the simulation. So when can the resets be applied? Resets can be applied during the start of the simulation and self-recovery circuits to start the circuit in a known state on power up, or it can be applied during simulation mainly to looping circuits to resolve states so simulation does not hang. Depending on the logical value of the reset that is applied, if the reset equals 0 or 1, it is considered as active low or active high reset respectively. But the most widely used reset is an active low reset, because by default if circuit is in power down mode, or if the supply is still ramping up, or if the supply is not available, a reset can be held low using ground and functionality associated with the reset can still be achieved. Applying reset is referred to as reset assertion, and removing of reset is referred to as reset deassertion. Let us look at resets and use of resets in Verilog. Delays in gate level modeling. Delays specify time in which assigned values propagate through the nets or from inputs to outputs of a gate. A gate can attain four states: a logic high or 1, a logic low or 0, high impedance or Z, or unknown or X. Unknown is only used in simulation. In real world circuits, there is only 1, 0, or high impedance. High impedance means a net is not driven directly by any value and is floating, thus it is dangling and can lead to any state. Gate delays are propagation delays of logic or gates, which is time taken for output to change to a valid and a stable value when there is a transition or a change or an event on an input. In other words, it is time taken from input to output. Based on these four states of a gate, a change of state is categorized into four different categories, and each propagation state has an associated delay. Following some basic guidelines, we can eliminate Verilog race conditions 90 to 100% of the time. For sequential logics, always use non-blocking assignments. For latches, always use non-blocking assignments as well. For combinational logic, in an always block, use blocking assignments. For mixed sequential and combinational logic in the same always block, use non-blocking assignments. Do not mix blocking and non-blocking assignments in the same always block. Do not make assignments to the same variable from more than one always block. Use $strobe to display values that have been assigned using non-blocking assignments. And finally, do not make any #0 procedural assignments.
Now that we have learned about how the ASIC design verification process works, it is very interesting to experience how these complex circuits electronic products are touching and changing millions of lives daily across the globe. Working on creating these amazing electronic products is even more interesting and challenging. Well, would you like to be a part of this change? Let us now tell you how Expert HDL and chip design can help you achieve this.
Expert HDL and Chip Design is one of the leading VLSI training institutes in India today. Expert HDL and Chip Design is founded by a group of industry experts who have real-time experience of more than 10 years in the ASIC design and verification domain and currently working for top global semiconductor companies in India and USA. We saw a huge gap between the industry and academia in VLSI knowledge, and that is when we decided to establish a VLSI training institute. Our main goal is to groom our students as experts in ASIC design and verification domain. Our courses will teach you the latest in ASIC design and verification methodologies as per the current industry standards. We provide specialized full-time job-oriented and short-term advanced skill certification courses in VLSI domain. We are the bridge between college and corporates, connecting students with semiconductor companies across the globe. Zero investment for corporates to find and recruit talented engineers in VLSI industry. After the success in in-class trainings, we have now launched a unique online training platform for all our skill development courses in VLSI. To enroll and to find out more of our online training programs, you can visit our website www.experthdl.com. Many engineers who have taken our courses are placed in top semiconductor companies in India and abroad. Our online training courses are taken by a lot of working professionals across the globe. So why should you take our course in VLSI? Well, the main reasons we see are due to lack of knowledge of VLSI, students do not even explore the career in this amazing industry. Fresh graduates who join this industry take up a long time to cope up with the technology because of lack of knowledge of the process. This also requires industry to spend a lot of money to train these fresh graduates, restraining them from hiring fresh graduates and instead invest in experienced professionals. So you must be wondering, what is so unique about this institute and why should you learn VLSI from us? Let us tell you some of the benefits. Experienced faculty. All our courses are prepared and delivered by our industry expert faculty who have real-time experience of more than 10 years in VLSI domain and have a postgraduate degree in electrical engineering with majors in VLSI from top-ranked universities in India and USA. Our uniqueness is that all our founders and faculty are currently working for top global semiconductor companies in India and USA. We have unique course offerings in ASIC design and verification domain with full-time job-oriented training and skill certification courses in IC design, digital design, Verilog HDL, System Verilog, UVM, Perl, Unix, and shell scripting. We are constantly working on adding more and more courses on different aspects of integrated circuit design and verification. All our training material is prepared and reviewed by industry professionals with lots of research. Our trainings will enable you to directly step into the industry with confidence. A certificate by Expert HDL and Chip Design will be awarded on successful completion of the course and passing the quiz examination attached with the course, which is very well recognized in the industry. Companies can check the authenticity of the certificate of a candidate by contacting us. The major benefits of learning from us is our unique, completely online learning platform. We are first of its kind training institute providing online training for courses in VLSI. Trainings are delivered in form of high-quality video tutorials accessible from within our website for various courses in ASIC design and verification domain. Each skill advancement course is very well structured into multiple lessons with high-quality e-learning content for each of the lesson. Access to this e-learning content online is valid for 180 days from the day of registration, which enables the individuals to learn the course at your own convenience and pace from any location. The content is accessible from our responsive website on any device like your laptop, tablet, or smartphone with internet connectivity and compatibility to play the video. Also, you can ask your queries to our faculty by sending a message just from within the course. Some of the benefits of online training are that for all the individuals who are enrolled in our online training, a hard copy of the training material is shipped to your registered address. This can become your golden reference manual. You will also be enrolled in a closed members group on LinkedIn with semiconductor company recruiters, industry experts, and other members. Take part in active discussions on various topics in VLSI and expand your knowledge database. And also learn more about what's going on in the industry and latest technological advancements. Get a unique opportunity to network with recruiters to explore new opportunities in semiconductor industry and get more visibility to your profile. All this from your desk at home or workplace and at your convenience and pace. Our trainings are most ideal for current students who are planning to pursue higher education in VLSI domain or planning to take up a job in semiconductor industry anywhere across the globe. Students can take advantage of our online courses to boost their knowledge in ASIC design and verification even before graduating without worrying about spending additional time after graduation to learn skills in VLSI. Our trainings enable you to get a head start in your career. Our certification boosts your profile. Our online trainings are most ideal for working professionals who want to learn or enhance skills in VLSI without the need to attend classroom trainings during or after your busy work hour schedule. Learn the skills at your convenience and pace anytime, anywhere. Our course content is most updated with latest advancements in the industry. Apply your learning real time at your work. Learn with us and get ahead in your career. Expert HDL and Chip Design also provides customized corporate trainings in ASIC design and verification domain. With our state-of-the-art online training solution, we help companies and teams get the skills they need to succeed in VLSI industry. We will customize the modules to meet your requirements. Bulk costing is available for multiple access licenses. You saw the benefits of online training. Listed here are our online training courses. We have certification courses in Advanced ASIC Design and Verification, which is our most comprehensive course covering all the modules. Digital Design Certification focused on fundamentals of digital design. Verilog Certification, which teaches Verilog hardware description language for design and verification. It is recommended to know digital design before you take Verilog certification course. System Verilog certification, which teaches the most widely used hardware description and verification language System Verilog for design and verification. It is recommended to know basics of digital design and Verilog before signing up for System Verilog course. UVM certification, which teaches the universal verification methodology, which is the most widely used and latest verification methodology industry standard. And they also have courses in Perl Unix and shell scripting, which is very useful for all the VLSI engineers. The course content is described in detail in the next slides. We also offer customized corporate trainings. Our goal is to make available all our trainings online so students and working professionals across the globe can benefit from our trainings. We are continuously working to update our course contents with advancements in the industry and also adding new courses in different concepts in VLSI. We are currently offering online training for Verilog hardware description language for design and verification, and will soon be adding other online training programs in a very short span of time. Please visit our website www.experthdl.com to enroll for one of our online training programs. You can send us an email at inquiry@experthdl.com for further details. Module 1 is an introductory module in VLSI, and we teach you with basics of VLSI terminologies and gives you the overview of IC design process. Module 2 is digital design and concepts. We cover all the fundamentals of digital design in detail, which will lay a strong foundation for learning Verilog HDL system, Verilog HDL, and verification methodologies. Today's integrated circuits are more than 90% digital designs. We start with introduction, then we go into the logic gates and combinational circuits. We cover all of the sequential circuits, design of synchronous sequential circuits, finite state machines, and all the fundamentals. Module 3 will teach you verification flow and methodologies in verification in detail. We start with what is verification, why the verification is important, ASIC verification methodologies, ASIC tools used for verification, followed by simulation and fundamentals of simulation. Module 4 is complete Verilog hardware description language course. Verilog, as explained earlier, is a very important and widely used HDL for IC design and verification in the industry. Current standard or extension of Verilog is System Verilog and UVM. The module is also an independent certification course widely taken by audiences across the globe. Module 5 is a complete System Verilog module. System Verilog is widely used in the industry due to its vast verification support for complex designs. System Verilog is more object-oriented. The module, along with the next module, is also an independent certification course. We go over the basics of System Verilog, fundamentals of object-oriented programming, integration of test bench and design under test in System Verilog, concepts like randomization, concurrency, and interprocess communications, and also cover what is coverage. Module 6 is an extension of Module 5, teaching advanced concepts in System Verilog, mostly useful for verification. For example, more details about object-oriented programming, factory patterns, virtual interfaces, connecting design under test bench and third-party modules, creating tests with System Verilog assertions, what are checkers and monitors, going into the assertions of System Verilog for verification. Module 7 is a complete module in universal verification methodology, which is the current industry standard for verification methodology. This course is an independent certification course, but we highly recommend you take along with System Verilog because of its wide extension of System Verilog concepts. We go over the UVM overview, the library basics of UVM, and then the test bench integration and entire flow in detail. Most of the CAD tools and work in VLSI domain is performed on Unix and Linux platform. Hence, it is highly important to completely familiarize yourself with the Unix operating system. Module 8 is designed to give you a complete overview of Unix and Linux operating system. We also teach you in detail Perl. Perl is a scripting language which is widely used by designers to automate a lot of the flow and to write handy scripts for local automation of tasks to be performed again and again. In the industry, many automation scripts are written around standard CAD tools to enhance the design and verification. We introduce to you Perl. We explain to you all the different data types of Perl, expressions in Perl, and how to write a Perl script. Module 8 is a complete module to teach you the fundamentals of Unix and Perl. We also teach you some basics of shell scripting. Shell scripting is very handy in writing some automation in Unix and Linux environment. So let me conclude by saying VLSI is a very interesting and a challenging domain to establish a career in. Lots of opportunities with demand for smart electronic products, rising opportunities and requirement of smart engineers to create these smart devices is on the rise. But to accomplish these tasks, it is required to use complex design techniques and sophisticated tools to manage these complex designs. The trainings offered by Expert HDL and Chip Design will enable you to achieve these goals and launch a successful career in VLSI domain. With the convenience of online training, you have the freedom to learn the course at your pace and interact with our experts and other members online. So go ahead and sign up for one of our online training programs today or contact us for more details. You can visit our website at www.experthdl.com to view our course contents in detail, to enroll for our online training programs, or contact us. Or you can drop us an email with your query at inquiry@experthdl.com, and one of our team members will respond to you soon. You can follow us on Facebook, LinkedIn, and Google Plus to get latest news and updates. Search for Expert HDL Chip Design. Thank you for attending this demo session on VLSI, and we hope you will sign up for our online training programs, or you can contact us for further queries. You can also view our demo on other topics for free before signing up for our courses. We appreciate your time.